So today I am going to talk about the time reversal. So let us talk about that. So consider a reaction is like this. Say these are the two particles A and P, and I represents initial particles, and Pi, these will interact. After interaction they give us the particle AF and BF, right? So if process is reversed, then what will happen? Reversed, then this will become incident particle, this will also become the incident particle, and after interaction they gives the scattered particle. So let us call it as AI prime, and let us call it as BI prime, and let us call it as the BF prime, and it is represented by AF prime. So if both processes would have same probability, the process is described as time reversal invariant. Time reversal invariant, and this is also known as microscopic reversibility. Right? So let us try to understand it quantum mechanically. This is basically a classical picture, so let us understand it quantum mechanically. So let us suppose a unitary operator. Let us suppose a unitary operator U U, and this operator, this is basically our assumption, so we changes t to minus t. That's what this operator will do. Also U commute with H, right? H is the Hamiltonian. That means HU is equal to UH, or you can write down it as U dagger. HU is equal to H. So if the system is in state psi, ket psi, so if system in state ket psi, the time dependent Schrödinger equation can be written as, equation is given by the time dependent Schrodinger equation is given by that h psi is equal to iota h cross curly over curly t psi. So let us operate both sides by u, means operating both sides by u. So if I operate both sides by u, then what will happen? Let us have a look at that. So it is u h psi is equal to u, so I h curly over curly t psi, as u changes t to minus t, so then we can write down it as u h psi is equal to minus iota h cross curly over curly t, and u goes with the psi, right? That's what will happen, right? So as we know that hu is equal to uh, so this can be written as hu psi. So hu psi is equal to minus iota h cross curly over curly t u psi. We can write down it in this way, right? So let us assume that this u psi is equal to, say, psi prime. So this is our assumption. If I put it in this way equation, then what we are getting, h psi prime must be equal to minus iota h cross curly over curly t psi prime. But due to this negative sign, we can say that that psi does not satisfy, that psi prime does not satisfy Schrodinger wave equation. Right? Thus time reversal operator cannot be unitary operator. Thus time reversal operator cannot be unitary operator. This we have to keep in mind. So to restore and to restore the symmetry, to restore the symmetry and to satisfy Schrodinger equation, and to satisfy Schrodinger equation, let us define an operator T is equal to uk, and here k carry out complex conjugation. Important thing is that here k carry out complex conjugation on anything that stands to right of it. right? So therefore T H psi, it can be written as H T psi, and it can be written as minus iota H cross T curly over curly T psi, and it can be written as iota H cross curly over curly T, it will be written as T psi, like this. You have to write down it in this way. So yeah, it should be written like this. Thus we can say that and this modifies to this, so using this, because here we have operated it with k, so this changes the sign from minus to plus because complex conjugation will occur. So therefore we can write down that H T psi must be equal to iota H cross curly over curly T T psi. And let us assume that T psi is equal to psi prime. So therefore H psi prime must be equal to iota H cross curly over curly T psi prime. So thus Schrodinger wave equation is satisfied, because this is like a Schrodinger wave equation. So we can say that Schrodinger wave equation is satisfied, right? So to summarize the results, we can say that for operator T, operator T is equal to UK, so which will perform two operations. First is the T to minus T and iota to minus iota, and the effect of this is that this will leave the system unchanged. This will leave the system unchanged. And also we have noticed that T psi is equal to, as we have stated earlier, that psi prime, it satisfies the Schrodinger wave equation. It satisfies the Schrodinger wave equation. So under this transformation, so let me summarize the result. Means under this transformation, quantum mechanical principle of microscopic reversibility probability holds, right? This we have to keep in mind. This operator T is called antilinear, linear, and anti-unitary. So let us now talk about few properties of T. Properties of T. So first property is one, that time reversal is not a linear operator. Time reversal is not a linear operator. On wave function, when it operates on wave function, means when T operates over alpha 1 psi 1 plus alpha 2 psi 2, then it will become alpha star T psi 1 plus alpha 2 star T psi 2, right? And that means this is not a linear, but if it can be expressed in this way, we can call it as anti-linear, right? And second property, property number 2. Let's talk about that. This is property number 2. So consider T and its effect on the function. Consider T and its effect on wave function. So for this, what we will do, let us take psi 1 prime is equal to T psi 1, and it can be written as UK psi 1, and it can be written as U psi 1 star, because it will do complex conjugation and this will change T to minus T, this U. And similarly psi 2 prime, it can be written as T psi 2, and it is UK psi 2, and it is written as U psi 2 star. So now consider their scalar product, that psi 1 prime and the psi 2 prime. It can be written as T psi 1 and T psi 2, and this can be expressed as psi 1 star U dagger U and psi 2 star, and it can be written as psi 1 star and psi 2 star, its complex conjugate, because this will become identity operator. And therefore we can write down that this if I summarize this, then psi 1 star, psi 1 prime and the psi 2 prime, its scalar product is equal to psi 1 and psi 2 whole complex conjugate. We can write down it in this way. Sorry, it was like this. Sorry, it was like this. It is like this, and it is psi 1 star psi 2 star, and it can be expressed as psi 2 and psi 1 whole star. and this is known as anti-unitary properties. This is known as anti-unitary property. So thus we have discussed two properties. One is the antilinear and the another one is the anti-unitary property of the time reversal operator. And let us discuss few points to remember, some important points. I am not talking about these details, but these you have to remember. So some important points. So under time reversal, following things will happen. Under time reversal, this x will remain as it is, its position, and momentum will change its sign. This iota will become minus iota, and where angular momentum will also change its sign, and this sigma will become minus sigma. This corresponds to spin. Also E will become E. This is for the electric field, right? And means electric field will not change, but the magnetic field will change its sign. So it is for the magnetic field. So these are the few results which we have to keep in mind, right? So that's all for the time reversal.